Hi, this video will show off one of the most popular uses of diodes, to make rectifiers. The job of a rectifier is to take an AC or alternating current input and turn it into a DC or direct current output. This could be used, for example, to take a mains input, which is AC, and turn it into DC. This circuit here has a 10 volt peak AC source in series with a standard diode and a resistor. This resistor emulates the load of our circuit. These two devices across the source and the load are voltmeters, which allow us to, as the name suggests, measure voltage. If you're not sure what a diode is or how they work, then please see the video in the link below, which should explain. Now, if I turn on the circuit, as you can see, the green signal shows a complete AC sine wave input, going up and down like that. Then, this sine wave passes through a diode, which, as we know, only allows current to flow in one direction, and because the current can't flow, the AC input gets cut in half, effectively removing the negative half of the wave or half cycle. Then, with the voltmeter across the resistor, we can see the sine wave is cut in half, giving us this purple half sine wave, where it rises with the positive, but then flats out in the middle to zero at the negative. Now, you may be thinking, well, that doesn't look much like a DC voltage to me. They're normally just a straight line at 10 volts. This is where a smoothing capacitor comes in. If you're not sure how capacitors work, then please see the video below. A smoothing capacitor's job, somewhat as the name suggests, is to smooth out a signal. I have connected a capacitor and a switch in parallel with the output, and if I connect the capacitor by turning the switch, you can see the output, the purple line, begins to form this strange ripple. What's happening here is when the positive half cycle passes, the capacitor charges, then when the blank half cycle comes, the capacitor slowly discharges itself, thus smoothing out the wave. If we want an even smoother output, then we must increase the capacitance of the capacitor. So if I disconnect it, increase the capacitance to say 10 times its value, then reconnect it, we can see the ripple output is now much smoother, similar to a DC output. However, when we use a diode to cut the wave in half, we are effectively losing half of our power, which is inefficient and wasteful. In order to solve this problem, we must construct what is known as a full wave rectifier. This circuit uses the same components as the half wave rectifier, only instead we need 4 diodes. This circuit can seem quite daunting at first, so I'm going to explain it slowly. In order for any circuit to work fundamentally, there needs to be a complete path from one side of the input over to the output and back to the other side of the input. When the AC signal is in its positive half cycle, let's imagine where the current will flow. Remember it looking for a complete path back to the source. The positive signal flows from this side of the source, up here. It can't go back through this diode, so it flows up here, through the load, round back through here, through this diode, and then completes the circuit, going from this side to this side. Now let's imagine where the negative signal flows, starting at this end, passes through here, can't go back through this diode, so it passes through this diode, round here, through the other side of the load, passes through here, back through this diode, and then down, once again completing the circuit. What we've proven here is that both the positive and negative half cycle are separated, but both make it to the load at the other end. If we now begin simulating the circuit and look at the voltmeter readings on the input and the output, we can see what we just explained visualized. The green sine wave shows the input going up and down, and the purple shows the sine wave sort of folded in half across the output. Now, much like our previous circuit, this can be improved by adding a smoothing capacitor to make the output more of a standard DC source. Now, as I connect the capacitor, as you can see, the voltage across the top starts to ripple. And then once again, the same as our similar circuit, if I disconnect the capacitor and increase the value, say to 10 times its size, and reconnect it, you can see the smoothing effect is much more flat, almost that of a steady DC output. Full wave rectifiers are much more energy efficient than half wave rectifiers because there is much less loss through the diodes. Thanks for watching, be sure to like the video if you liked it, subscribe if you loved it, and have a good day. See ya!